Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Welcome everyone to the GOTO Book Club. We are here in Amsterdam now, and I'm Alyona Galyeva from Pitfalls Amsterdam and Thoughtworks, and I'm here to introduce you Katharine Jarmul.
Hi, I'm Katharine. I'm so excited to be here with you. I'm also at Thoughtworks. I work right now as a principal data scientist. And we're here, I think, to talk about my recent O'Reilly book, which is called Practical Data Privacy, and is aimed towards data folks and technical folks that want to learn about privacy. So really excited to chat with you about this today.
Cool. I'm excited too. Oh, probably all are excited. But anyway, so I was curious, what exactly inspired you to write this book in the first place?
Yeah, I think probably a lot of things. First and foremost, I've been working in the field of data privacy and data science and machine learning now for multiple years. And I think I learned a lot the hard way. So when I first got interested, I started asking questions like, okay, is privacy important in machine learning? How are we going to do it? How would we even go about that? A lot of the material that was available was either really high level, really basic stuff. So kind of older techniques, maybe even sometimes broken techniques that we wouldn't recommend anymore. Or it was hardcore research. It was you're a PhD in differential privacy. Here's a paper. Let's go. Or here's a paper on cryptography. Figure it out yourself. And I think that through that learning was probably a lot of battles I wouldn't have had to do. So kind of the idea of the book is really a gift to me 5-6 years ago. These are all the shortcuts that you eventually find out the hard way. Here's, if I had to teach it to you again, here's how I would teach it. And kind of the goal is to demystify the field a little bit of privacy engineering and basically just of technical privacy in general and get more people into it, because I think it should be more accessible, easier to understand, fully, if we want to use the term democratized, but available for more people.
Wow, I think that's nice. It's a gift back to me and the rest of the folks. I wish, we have more such beautiful books available where you can just go, I just need to tap to this knowledge. Ding, ding, ding. Ready, the next one.
That's your book, right?
Yeah, fantastic. So before, let's say, deep diving a little bit more into this book, I just want to highlight the specific terms that we're going to use, because based on my personal experience, I noticed that there are a lot of terms that used interchangeably. So what I'm usually hearing in the room full of enterprise architects when the data topic pops up, it usually starts with, let's say, we need to protect data, of course. And then we go, we need to protect data. So what techniques we're going to use? We're going to use pseudonymization. We're going to use anonymization. We're going to use this and that and that and that. And I have a feeling that it's all different techniques. Mm-hmm. It's all different meanings. Mm-hmm. And the end result, how the data looks after all these techniques, that's what's usually really underestimated, because we're forgetting about the data consumers, such as data scientists, data engineers, data analysts, and the rest of the folks. So could you probably walk me through a little bit? Are there any difference between them, or just you can use them interchangeably?
Yeah, absolutely. And I think you're highlighting a key point, and I know it's been a pain point that you've probably experienced in your life, right?
Yeah.
I want to even zoom back to data protection versus data privacy. Those are actually also different fields, right? They're overlapping fields, But data privacy is also like a social and cultural understanding of privacy, and maybe also relates to individual experiences and feelings and like how we want to share things and how we want to change how we share things. And then we have data protection, which is really like a lot of the laws around data privacy are around data protection. And maybe that also borders on data security, which
Compliance.
is also different, and InfoSec, which is also different. And so we have all these like neighboring things. And I think if you're just an architect or a software person, you may just think like, oh, those are all the same words and they mean all the same stuff. And that's not your fault. Like probably lots of people have used them interchangeably with you, but let's correct some of the problems here. I think you point out pseudonymization versus anonymization.
That's usually what just mixed up constantly.
Massively different things, massively different outcomes. I mean, technically, pseudonymization is all we're trying to do is we're trying to create some sort of placeholder or pseudonym for maybe even personal identifiers. So maybe we shouldn't release the name or the email. So we create a pseudonym. We can use many different methods. So within pseudonymization, there's subfields like masking, tokenization. Of course, you can always use redaction. That's slightly different. You can even do format preserving pseudonymization using methods of format preserving encryption. You can do all of these different things, but those is a subfield of pseudonymization. And then we have anonymization. And I'm here to break it to everybody, and I'm sorry. Anonymization actually doesn't exist. Like if we collect data, if we collect information and we release information, there is actually mathematically no guarantee that we cannot have somebody learn something about the individual. And so the true, like the dictionary definition of anonymization, which is like, you can't learn anything about the individual. You can't have the potential to re-identify the individual. That's actually been mathematically proven using math and logic and information theory that it's actually just impossible. That's okay. That's okay. Because even though it's not technically possible, we have now defined methods to, let's just use the term anonymize, or to approximate the best way that we can anonymize data using techniques like differential privacy. And I'm happy to talk further about it. But there's ways that we can try to think about the information that we're giving out and think about what the implication of that information is for the privacy of individuals, and to rigorously define and measure that and to tune that for, as you say, the exact use case, right? Because at the end of the day, we have some users. They might be data analysts, they might be business users, they might be, the users themselves, they might be data scientists or machine learning folks. And they're the ones that actually have to then consume this data and make decisions with it, or potentially lead the company in certain directions. And we need to be very clear, like, what's their needs too in this. So we balance the user needs for privacy and the data needs for information.
Yeah. Okay. So like short summary, pseudonymization, anonymization, it's not the same thing. It's different. And let's say the classical anonymization, like 100% guarantee doesn't exist. Yeah. And just get back to that point. I think we're gonna deep dive further into differential privacy, of course. But what I usually see in the, let's say, boardrooms, that this little bit binary approach to, let's say, how our data could be secured. It's like, or it's secured or not. And this is usually all conversations that we have with InfoSec folks, with compliance folk, like audit and all of that. Like, and if it's a huge enterprise, you have, of course, a data governance board, and then it goes more and more and more and more. But I think what is really fascinating with differential privacy, that this is the first time when you can think about, let's say, the data protection as a specific scale. So it's not, let's say, or protected or not protected anymore. So could you explain more about that? Because I think that's the most tremendous concept that is introduced in the chapter 2 of your book.
Yeah. And I think it's even almost bigger than that too, because it's like pseudonymization is also a method, and that offers some privacy guarantees. Then we go into anonymization, differential privacy, and then we can go even further of like federated use cases and all of this stuff. This stuff from our conversations, but it's all in the book too. But I think I love this thing that's like privacy isn't on or off. Data protection isn't on or off. It isn't like I switched on the data protection, magically everything's protected. And it probably never was. So if, unfortunately, we have this kind of idea, do we implement the security? Do we implement the protection? This is a very binary mindset. But that's not at all how any of these technologies work. And we know from our work in data, it's also not how data and information work, just by default, right? Like when you're working in machine learning, as you and I have had a lot of experience in, there's a variety of truthiness of the data, and there's a variety of protection of that data depending on how you implement your algorithms or your architectures. And so I think cool thing about differential privacy, it's all tunable. So it's by default tunable. And the base theory of differential privacy is the idea of tuning the amount of information that somebody can get from the result and tuning that and bounding it by a small probability bounds. So I give you an answer.
Yeah.
And let's say the answer is 10.
Yeah.
Whatever the answer is. How many purchases users in this area made in this month or something like this?
Yeah.
It's 10. Okay. And then I add a person to the data set, and maybe the person falls in that query. Then you ask me again, and the change in those answers, so 10, let's say, then now I say 11. It's like if I just answered you 11, you could make a pretty good inference that somebody got added and that person made a purchase.
Yeah.
And the goal of differential privacy is to add essentially some uncertainty in whether the answer was actually the answer. And in doing so, allow there to be some of this probabilistic thinking in how certain am I that a person got added or not. And so we can think of this like a really good example, I think, is like salaries.
Yeah.
So let's say there was like a dashboard of all payroll, right?
With some buckets probably.
Exactly.
Yeah.
And then a new person got hired in your team, and you're of course quite curious because all people are curious, and you're like, I wonder how much this person's getting paid. And maybe
it's really a sensitive question, especially in the European Union.
Exactly. And maybe the person doesn't want to share, or maybe you don't want to ask, and whatever. But if the dashboard just reports all of the actual numbers, there's a pretty good chance, especially with some data thinking and probabilistic thinking or statistical thinking, that you could reverse engineer the salary. And what differential privacy tries to guarantee by using differential privacy mechanisms is it tries to, again, add some level of noise, some level of bounding, so constraining so that outliers are essentially non-existent, because outliers leak a lot of privacy.
Yeah.
And then adding this probabilistic noise so that even the people running the system, they can't determine how much noise was added. And this uncertainty and this, like the tuning of the noise, can help you tune this amount of privacy guarantees versus the amount of information. And of course, in an internal use case, maybe you want less noise, more information, but then you also have less privacy. And maybe if you're releasing data to a partner, to a third party, or to the public, maybe you want to actually tune up that noise, and it's okay that it's not 100% accurate for whatever accurate means.
So could we say that in this way we try to protect data from, let's say, reverse engineering?
From privacy violations. So essentially what we're trying to do is we're trying to de-risk the release of information for whatever we define as an adequate privacy risk. And this is where like the thinking in privacy really overlaps with security and InfoSec thinking, because it's about what is the actual risk? What's the threat model here when we release this data? What are we worried about? And how do we then adequately tune the protections that we have, or employ or implement the protections that we have that's going to adequately mitigate that risk? So we feel safe, and we feel like maybe our users or our citizens, if you're a country, are safe. and we can release this data. And so it's pretty cool. The library that I use to implement differential privacy in the book is Tumult Analytics. It's an open source library. And they were the folks that helped the US Census release differentially private census data for the first time in 2020. And they just last week, and of course, there'll be some delay in the release of this video, but a few weeks ago now, at this point in time, they just released all of the Wikipedia data with differential privacy, which is pretty cool, I think.
Whoa. And I just want to, let's say, to halt at this moment. So we usually see that, especially in any data projects, usually the privacy, this is like the last step. The compliance is the last step.
Yeah.
And also take into account the upcoming EU AI Regulation Act, which indicates specific, let's say, high-risk industries, high-risk use cases. So I'm really wondering how you can structure the process in the most mutually beneficial way for software engineers, for InfoSec, and for data folks. So what you're going to do, let's say, step by step, what is your recommendation on that?
Mm-hmm. And I think like we've seen a lot of this happen in governance and risk conversations. Exactly. And I mean, it's going to be different for every organization, which is why it has to be led by those experts. And I think you named them very appropriately. It has to be the software infra architect side of the house. It has to be the data side of the house. It has to be the security side of the house. And if the company is large enough, as you referenced before, it has to be compliance, audit, privacy, legal. And those people should all be sitting on the data governance board by them, with talking with each other regularly. Let's hope. If not, maybe that's the first step. And that's the first chapter of the book is like, if you don't have functioning data governance, you can't do any of this cool stuff. So you need functioning data governance first, because as you point out, there has to be a risk appetite set. Mm-hmm. So you have to define what is privacy risk for us? What is data protection risk? What is information security risk? How do we define that? How do we define it on a data science or a data case-by-case basis? So for certain things, do we have a larger risk appetite? Like, are we willing to take more privacy risk on to do a new cool machine learning thing that we want to test out? But that all has to be defined at the organizational level. And once that starts to get defined, you can actually work with teams to prioritize experiments. And that's often, that's very much the Thoughtworks way, is identify a priority, identify a thin slice, and then iterate on it, and as very agile methodologies as well. And I think that actually works really well for these new technologies because they're so tunable, because some of them have different requirements in terms of how to deploy and scale them and so forth, that on a case-by-case basis, you experiment with some of these new technologies. You iterate and learn, as you always do. And then maybe as you iterate and learn, you can build them into platform services. Maybe you can build them into reusable functionality that your teams can leverage. And that requires, obviously, the software folks in the house and the platform folks in the house to really think through how do we optimize these systems for scaled use and for the types of users that we have. And so it can be this huge iterative process. And then you go back to the governance board and say, okay, here's our learnings. Like, what's the next priority? And it can iterate that way too.
Okay. So let's, for example, zoom in into the use case. So you're in the room, there's a specific use case. We're not talking about mission critical scenario right now. We're just talking about something that we would prefer to do better. Mm-hmm. Let's put boundaries. It's for internal usage. So it's still, let's say, private information, but like we're not releasing this information somewhere external, the company. So what will be the hands-on approach? You briefly mentioned the library that you use. So how are you going to go? So you have this use case, you have this like software folks in the room, data folks in the room, infra, privacy folks in the room. So what are you going to do?
Yeah. So, I mean, there might already be policies and standards that say like for these use cases, this is what we recommend. And depending on the org you're at, they might be super specific and say like, use this library and with these parameters and so on.
So you can even define a perimeter.
Exactly.
Wow. Okay.
If you wanted to, right?
Yeah.
And that's usually for organizations that have been doing this for a long time. That's why they don't have to have so much experimental. They've already experimented. They've codified it in their policies or their standards. But there's also a lot of orgs that don't want to codify it in standards because they know technologies change over time. So you definitely go to the guiding standards and policies. You'll kind of, hopefully by that point in time, read and understand a lot of them. And then to actually implement them, if you can leverage a platform that's already there, if you can leverage a tool that's already there, always do that. Nobody should be rolling their own of any of these things, in my opinion, unless you have, a privacy engineering team that's in charge of this. In the case that you described, so like internal data use, not going to be released publicly, you might even just decide pseudonymization is enough. Okay. Or you might decide like aggregation plus pseudonymization for these particular categories is enough. So there can be, I think, particularly for internal use cases, a much larger risk appetite because presumably with your internal users, there's a high level of trust. Yeah. If you're in a huge org, and this is one of the things that they did at Google, is for data scientists, you have to first prove that your experiment idea works with differentially private data. Wow. Before you can get access to the real data. Wow. And this is for the sensitive, PII and other types of sensitive data. And I think that's a really cool idea that can be used in all sorts of industry where it's like, look, maybe you're just in the EDA step, the exploratory data analysis step. Yeah. Maybe you don't need the raw data. Maybe you just need some artifacts of the raw data to just test out the idea. And then if you want to go further, maybe there's a process to apply to get access to the raw data. And maybe there's a time frame of experimentation. So maybe instead of accidentally, I think a lot of times accidentally having access for like 2 years. Oh yeah. And then you accidentally pull production or something like this. Like you don't want to do that either. So like it helps the users and it helps the organization to like have a little bit more structure around how some of this more exploratory data works, and then to define, okay, once the experiments are run and we know the approach and maybe we want to move into staging or even production, then we essentially decide to give less access to the individual data user and more of a systems level MLOps. I know near and dear to your heart, MLOps layer of access to the data, which is great, right? Because then the chance of somebody accidentally pulling production or accidentally exposing users is much less.
Yeah, definitely. And I think that's the most difficult part because usually it's like, yeah, we can do this because we don't have access to production data. We couldn't create synthetic data based on that. So I'm just wondering how, in this case, let's say specificity of, of the usage of the specific libraries and the tuning of the specific parameters that you just mentioned. Probably we can zoom in a little bit more. So I just want to, so imagine we have specific, like the database from this database, like we operational database on a specific moment, we just scoop specific amount of data. We have, let's say, a data processing pipeline, which has, as we guess, some embedded data verification checks and also apply probably like application of differential privacy. And then we have, let's say, the end result. So what type of these parameters you can tweak? That's what I'm really curious. So if you look at the differential privacy, what are the main concepts of it? And this concept, let's say, then turn into parameters, and what could be explained, let's say, in the simple words. Because if you go into all the privacy budget with Absol and how it's for, it could be too much. But I would say, if I need to explain it to my software colleagues, what I'm going to do.
So, perfect example, right? And one of the problems and also beautiful things about differential privacy is now we have actually hundreds of definitions. And those definitions have different parameters. And there's some ones that you can use as kind of like hyper parameters to optimize different definitions. And so it can get quite complicated. Damien Desfontaines, his work on it and his article series on it, he helped me with the differential privacy chapters as a technical advisor. And helped implement the Google differential privacy stuff, and now is at Tumult Analytics place. And he and a co-researcher whose name now I unfortunately forget, they did a survey paper, and they parameterized all of the parameters. So there was like 100 different parameters.
I'm trying to imagine dimensionality of this data.
Exactly. Yes, absolutely. So, but let's zoom back. Like, let's go to more a simpler definition. And then depending on the privacy expertise, or if you start hiring privacy engineers at your org, then they can go dive into the deep end.
Yeah.
But from a simple standpoint, we're going back to these queries that you're running. What you want to understand is, what's the probability of learning something before in the first query? And then what's the probability of learning something in the second query? And you want those probabilities to be very close to each other, because the closer they are together, the less information that you've essentially given away. And the less information you've given away, the less of a chance of privacy loss.
Yeah.
So privacy loss of the individual is information gain of the person querying. And these are modeled in like a threat modeling sense, like the person querying is like trying to attack. And therefore they can be relaxed for different types of use cases. If you're releasing data publicly, you should probably think about a very high, high level of security and low level of trust with the people using the data. But if it's internally, we can think we can broaden that. And one of those parameters that you can tune is that closeness of those responses. Do they need to be tightly coupled? So we have very high security, but also probably a lot of noise. Right? So the noise distribution that we're pulling from is much larger in a sense, and therefore we have much higher uncertainty of if the answer that we got the first time or the answer that we got the second time, if there's any information there. But at some point in time, it also gets too noisy, right? And then we need to determine how to do that. And so I think like the higher accuracy that you want means less of a chance of privacy for the individuals. So if you absolutely 100% need the right answer and it's mission critical that you get the right answer, then probably differential privacy is not for your use case. But if an approximation of the right answer, and this is like also theoretical debate in data, is what is ground truth? And do we ever have accurate data and all of these things? And so I think there is something to be said of how much do we understand the data that we're collecting? And is there not already error in the data we're collecting? And does the insertion of differential privacy related error, so errors so we can ensure privacy for the individuals, which is essentially what we do as part of this process, is we insert error. And we can decide what type of error, so we can choose the distributions that we insert, so we can use Gaussian, which we would normally expect anyways in data we collect. So as data scientists, we expect like normally distributed error in most of the data we collect anyways. And so inserting some more normally distributed errors is probably not the end of the world, as long as we're doing robust data science. But this is these are like all things to think about from a software perspective. You need to think about this trade-off between the accuracy of the response or the information of the response and the privacy you can guarantee, and the mechanism in and of itself. And what you can tune is this tension between those 2 points. So either you're getting more privacy and also more error and noise, and also for the attacker, less certainty that they know for sure what the data is or who's in it, or you're getting, higher accuracy, closer to the actual numbers, but the chance that somebody learns that somebody got added to the data or that somebody got removed from the data or certain things about the people in the data is much higher. So therefore you're dealing with much riskier data science or data release.
Okay. So literally, let's say in my head, it's like this slider, which going is like how much privacy loss we could afford to get meaningful results at the end versus how more we prefer to lose to get, let's say, better results. So that's, let's say, the space where we operating.
Absolutely.
Okay. Yeah, I think it's usually like everything is trade-off in the majority of the cases. And that's exactly the trade-off on which sensitivity of data we need. I just want to get a little bit back. I think what triggered me when you mentioned that this Google approach was really interesting. So we're getting back to the story of, let's say, again, data in different environments. So usually, of course, you're not allowed like high risk, sensitive PIA data to be available in dev or staging. You prefer to keep this data in production. But what I saw with my own eyes, like 2 eyes, that usually like there's only one environment. It's only one environment. And let's say then there is no understanding where the data folks could be put in to do their experiments. They're not allowed to do their experiments in production because it's production. There is no infra to do this, of course, for all the hungry computations. And then usually it goes like, if I cannot access the data, then I find someone who can help me to access the data, right? So we go this way. Oh, probably you can send me this 3 gigabytes, as like attachment to the email. And imagine if it's PIA data.
Yes.
Good luck with this. So again, like in this like chaotic situation, what will be your piece of advice? It doesn't matter like right now the scale of the company, but imagine they don't have anything and they just want to start. Mm-hmm. Mm-hmm. How are you going to approach this?
Yeah, absolutely. And I think like this goes back to the very basics of data governance and the fact that like if you have a system that cannot support an entire department or team of people, except for going around the data governance rules, you haven't done it right. And we see this a lot, even at scaled companies, where data governance comes in and like with very strong, hard rules of like, no access for data teams, no this, no that. Although that might be a great idea for information security, people are clever and people are social. And social and clever people will find and socially engineer new ways to access data. So just saying no all the time is not going to stop data from being used. Instead, implementing privacy engineering at an organization, even if right now you call it infra engineering, you put it in the architecture, you put it in software, wherever you put it, the concepts of privacy engineering, which is making these technologies easier to use and more available for the entire organization, that stuff has to be built in to avoid these shadow IT systems and these workarounds that people find, because people need to do their jobs, right? So just saying no and blocking access to production data or something is not going to stop data scientists from figuring out a way to do that or leaving the org. Even worse, getting so frustrated that they can't get access to data that they leave the org, and then you don't have any data scientists anymore, or you don't have data scientists that want to do daily data science, right? Which is also problematic. So I think you have to go back to an organizational decision. We're going to invest in ways, and if you're a small org, you can make these small ways, right? This can be a simple interface that allows for pseudonymization, that allows for tokenization or something like this, or an interface that allows for an aggregate dump from production to go through a differential privacy pipeline or something like this. You don't have to do everything at once, but you have to give people the tools they need to do their job and the tools they need to do their job safely and with privacy respecting tools.
So I do believe as well that it's like from the day one, it should be built in. Yeah. If it's there, then it's easier to expand it later, but there is nothing here. If there are even no categorization of the data, like regarding what is the sensitivity of specific data, and then a basic, let's say, the way how the users can access the data without specific like role. If you have just like, we give everyone root access, so good luck with this later for the use cases. Yeah, that's really, I think, the hard thing. I also wondering, if I look back, for example, pseudonymization, usually the vector of attack is usually, let's say, this like linkage between pseudonymized data and, let's say, the original data, or it's like some dictionary or any other thing. So that's usually what attacker try to get access to. What will be the vector of attack in case of differential privacy?
Yeah, I mean, I think, so differential privacy, you tend to release aggregates, things like histograms, things like count sketches and other things like this. But you could also release a result, right? So you can release an average or something like this. Interestingly enough, some of the core differential privacy attacks that have been proven are basically implementation errors.
Oh, wow.
So Damien, the same researcher who's done a bunch of work on differential privacy, will be presenting at B-Side Zurich this year some work that the Tumult team did on leveraging floating point attacks against differential privacy systems. And we can think about this like when we're in floating point, and we're already then that's already an abstraction on how computers store data, right? There's no real floating point data type at the core processing level. And so we're dealing with some sort of abstraction. And what has been proven before and what they further proved is depending on how the sensitivity of how you're sampling this noise, the computer can sometimes not be truly pseudo-random. These are some of the same problems we have in cryptography and so forth, as well as with computers, we don't actually often have a true source of randomness, at least from a mathematical perspective. And so let's say that you're an attacker of a differential privacy system. If it's quite obvious that you're running a query that has a particular distribution and the sampling of that distribution is predictable, you can start to reverse engineer. We can think of this from Bayesian or probabilistic thinking. You can start to reverse engineer these processes, and you could potentially even start to guess how much noise was added. Obviously, if you can guess how much noise was added with any certainty, you immediately remove all of the privacy guarantees, because the privacy guarantees come completely from the fact that nobody can probabilistically infer how much noise was added. And so the whole cards fall apart if you could do that. But it's more, interestingly enough, it's less from data analysis, and it's more from computers and systems analysis that have been most of the attack vectors against differential privacy.
Yeah, so now I guess I get it, why there is no such a thing, this 100% percentage guarantee of anonymization. So with all being said, we try to walk through, let's say, different chapters a little bit, touch different things. So I want to go to summarize all of this. So could you briefly walk me through let's say, what is the more or less content of the chapters, how many chapters the book has, what the content, and this is hands-on privacy implementation book.
Yeah.
So just highlight this, and I think that will conclude our session for today.
Yeah, thank you. Yeah. So as you're familiar with already, and as hopefully viewers will be as they read the book, is the chapters are structured so there's theory first, and then there's hands-on stuff in the later half of the chapter. And this is because I'm a practitioner like yourself. I think it's really important to not just teach people how something works, but how they can use it.
Exactly.
Okay, that sounds great, but what am I going to type when I sit down? How am I supposed to do this? And so each chapter has open source libraries. So we start with data governance, and we talk a little bit about pseudonymization and so forth, and then move on to differential privacy. You get to play around with the Tumult Analytics library. Cool. There's also some implementing differential privacy by scratch, which, by the way, you should never do unless you're
I remember
expert.
This. Don't do that. Don't do that.
I teach it to folks so they can play with it, right? Because it's important to play with these mechanisms and kind of reverse engineer how they work so you can reason about them. Then it moves into data pipelines, data engineering. So how do you put privacy technologies into data pipeline work and data engineering work? Then it moves on to attacking privacy systems. So how can we because we need to know how to attack stuff if we want to know how to protect it. And then we move into federated learning, federated and distributed data analysis, which we didn't get to talk to today. But then you use Flower, which I love Flower to do this. And then we go into encrypted computation. And this is just computing only on encrypted data without decrypting it. Encrypted machine learning, encrypted data processing, and how does one do that? And then I started to go into the human side. So how do you read policies? How do you work with lawyers? All of these things, and then some FAQs and some use cases. So it's a pretty fun wild ride, I hope.
I do hope.
Open for feedback if there's open questions. And yeah, it's been really exciting to chat with you. And thank you so much for being my host with the most.
Yeah, thanks a lot. And I guess the folks can get your book because it's right now available. So you can find it, digital copy or hard copy, whatever you prefer. Thanks a lot, Katharine.
Thank you so much.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.